Okay, number 49 on section 4.2, we're supposed to find the limit of the sum as the number of rectangles approaches infinity. We're trying to find the area under this parabola here. I've shaded it in red off to the side. And what we're going to do is we're going to divide it into an infinite amount of rectangles. That's why we're taking the limit as n, which is the number of rectangles, approaches infinity. And I need to take the infinity of the sum. So what I'm going to do is not really copy down that limit n approaches infinity each time. First, let me just kind of work on developing the formula for the sum. All right. So we want the sum as our rectangles go from 1 to infinity, okay? And so I need to think about each rectangle. I'll just draw a sample one here. What's its width, what's its base, and what's its height? Well, its base is going to be, we're going to divide this into infinite rectangles, but I'm going from 1 to 0, so I'm going to say 1 minus 0, and then I'm going to, go to infinity, but I'm going to call that n right now. I'll take the limit later. So my width, or my base, is going to be 1 over n. So I'm going to write that first, even though that's kind of what we're going to call our change in x in section 4.3. And usually we put it second. I just put it first because it makes it just easier, I think, to do the algebra. Now, what we're going to have to do now is find the y value for each one of these rectangles. So it's going to be up here on this black curve, this parabola here. And so what I have to do is basically plug that x value into the formula. Well, the formula is something squared plus 2. And what I'm going to do is it's I over n. Now, we're starting at 0 here, so this makes this one easier. We're going to see in section 4.3, they're not always going to start at 0, and it can make the math a little more difficult. So it'd be like 0 plus I over n, and then so it would be 0 plus 1 over n, then 0 plus 2 over n, then 0 plus 3 over n as we loop through that sum. Okay, so I've got this. Now let's go ahead and start working on it. Again, this 1 over n is my base, and then my height is represented by the part in the rectangle. Now what I'm going to do is I'm going to go ahead and I'm going to pull that 1 over n out front just to make my algebra a little bit easier. And so this is going to be the sum of I equal, and again you may have to watch because it's hard to get this app is not great, but it's all I got. So I've got pull that out, and then I'm gonna, what would I have left? I would have this I over n squared. I'm gonna go ahead and square that. That would be I squared over n squared. This is difficult. Plus 2. And I'm taking the sum of all that. Okay. So now that's going to be I over n. That would go with both terms. But I'm going to separate these two terms into sum of two terms into the sum of the two separate terms. So now on this I squared over n squared, which is really hard to read here just because of, I'm working with what I got. I could pull out I could pull out 1 over n squared. And so now I got the sum I equal 1 to n, and what's left is I squared. Do you see why I did that? I want that part that I got the formula for all by itself. All right, so I got that. So now, let's see, I'm going to move to the second term. Now that's the sum I equal 1 to n of 2. Now that is pretty easy to get. That's actually going to all be 2n. Remember, you got a constant, you just put the n with it. So in the next step, I'm just going to write it that way, and I'm just going to go ahead and say that's what it is to save myself a few lines of writing. So now I have 1 over n times, let's see, now this, and then inside here, I've got 1 over n squared. Now the formula for this I squared here, and again, this 1 over n squared just goes with this first sum here. That formula is, let's see, for I squared, it's n times n plus 1 times 2n plus 1 all over 6. Okay, so that's that whole thing. And then I got that plus 2n that's written in blue up there. Now remember, this 1 over n is eventually going to go with all of that. Go to another page. So now I'm going to go ahead and distribute the 1 over n. So if I distribute it to the first term, I'm going to get 1 over n cubed, it's a cube, times n times n plus 1 times 2n plus 1 all over 6. Okay? And then I've got 2n over n. Now remember, I'm going to take the limit of all this in a minute. I'm just not keeping up with that limit notation because it's just makes it, I think it makes it easier just to kind of get this set and then do your limit at the end. All right, so now let's see what we could cancel out here. 1n here could cancel out with 1n down there, so that's going to leave me with an n squared. And then these are going to cancel out, and that's just going to become 2. So now I have an n squared and a 6 on the bottom of this first big term here, so it's a 6n squared. I'm going to go ahead and FOIL out n plus 1 times 2n plus 1. That's going to be 2n squared plus 3n plus 1. Okay, all over 6n squared, and then I've just got a 2 down here now. Okay, so now what I'm going to do is split this this fraction up. Remember, if I have 1 over 7 plus 1 over 7 plus 1 over 7, I could write that as 1 plus 1 plus 1 over 7. So I can either write it all together with one denominator, or I could split it up. So I'm going to split this up into separate fractions now. That's 2n squared over 6n squared plus 3n over 6n squared plus 1 over 6n squared, and then we got this plus 2. So the n squareds will cancel out here, and then this will become 1/3. So actually I've got a number here. 1/3 plus 2 is going to give me 7/3. I'm going to go ahead and write that down here. Now here I get a 1 and a 2. And then n goes into once, and n goes into n squared n times. So now I have plus 1 over 2n, and then I got plus 1 over 6n squared. So now what I'm going to do is I'm going to do the limit of all that. I'll write it in blue. So now the limit is n approaches infinity of all that stuff. I'll write it down. I'm just going to draw an arrow to show you that's where I'm going with it. Of 7/3 plus 1 over 2n plus 1 over 6n squared. If I plug in infinity, 7/3 is still going to be 7/3. If I put infinity over on this 1 over 2n down here, that'd be 1 over infinity. That would go to 0. And likewise, this 1 over 6n squared term, if I plug in infinity in the base, that's going to be 0. Therefore, my limit is 7/3, and we are done.